Thank you. Sorry, slight problem. I've been 10 years at Microsoft, so Mac is new to me. So quite an onboarding experience at Lyft. Hi, my name is Sacha Faust. I've been doing security for about 20 years. I don't feel too old. It just means I have a lot of experience. I've made plenty of mistakes before. So we're here to talk a little bit about building intelligence graph. Like, what's the value of this? Why did I start building into it? What were some of the reasons why I looked into that problems? So overall, in terms of agenda, is some of the challenges I've seen in security overall. 20 years, I'm missing patches of hair here and there. I've definitely banged my head against common problems at different companies. I did the startup route in the late 90s, went into hiding after the dot-com boom into consulting, and then went back into hiding at Microsoft for 10 years, primarily focused on security, and ended up my career leading the Cloud and Enterprise Red Team, which was quite interesting. And recently moved to Lyft back last November. So I've seen a few challenges, some in more political than other environments. I would say Lyft is not that political yet. So we'll go over some of the challenge, Intel service overview, like sort of the how, the what, and the why, and some of the use case as well. So the use case are going to be pretty basic, kind of exploring a little bit what I personally try to do in Q1 since I just joined. But it's kind of an overview of the direction Lyft is taking in terms of risk management, automation, and exploration as well. So a lot of companies are using the stick and carrot approach. I've seen it work. I used to think it used to work. I've learned over the years that it doesn't really work. There was a great presentation I've seen called The Puzzle of Motivation from Dan Pink that basically said at some level the carrot and stick doesn't work, is self-direction is better. Enable people, and the really motivated people are actually going to go do the right thing as long as they feel enabled. So the carrot and stick approach can sometimes work. I've asked plenty of people, especially when I was interviewing last year, about what is a true security carrot, and the answers were a little bit unsettling. And I thought I was talking to some of the leaders in the industry. We're talking about like some of the basically big companies. And the gist of it was, the answer was accountability. It's like, well, our carrot is we drive accountability towards engineering teams. I says, what does that really mean? Like, how do you enable them to actually have accountability? And they said, well, we're not quite sure. So it was a little bit unsettling conversation. I've seen a lot of security teams use the stick too much, basically jumping right into conflict from the get-go, and in some cases never getting out of conflict. Some of them get out of conflicts and drive more in terms of compliance. Like, the people are kind of doing what they're being told because they need to. That's not really an approach I personally believe works, more towards commitments and teamwork. So how does the security team actually enable teams to make the right decisions and create this partnership so that we all work together? There's this very constant fight between red and blue. At the end, in enterprise, you're all blue. So you got to work together. We're just kind of separating the duties there. Very common issue I've seen is communication. You see one person is saying, this is high because it's in Korean. It says, because I said so. And the engineers on the other side says, no, it's low. And the translation is basically because my focus is making money, right? So there's this huge communication problem in the industry. And that's basically been a deterrent to actually make progress. And again, it's always around like right away, right off the bat, if we don't communicate well, we're right away into a conflict problem. The other issue is that a lot of engineers are looking at dependencies. They're looking at software dependencies, but they rarely look at other people, other teams. Like, if your team is depending on another service, you're basically depending on that team, right? So building this sort of human connection that we're all depending among each other is something that I think we need to revisit as part of in the industry. This leads into building empathy within your offensive teams. Don't point fingers all the time. Be a little bit more diplomatic. But the overall is that we're all dependent. And the reality is that we're completely blind about a lot of our dependencies. A lot of business holders are, to some extent, blind to the risk that they're taking. And it's not an intentionally blind. Hopefully, your CISO is not intentionally blind. But the reality is that there's no way to visualize, no ways to explore these things. So that we're kind of running with blinders on. And hopefully, one of the sort of bad events won't happen. The reality I've learned at Microsoft, and I've learned this the hard way, not once, but multiple times, is assume breach, right? You can invest as much money as you can into protection. The reality, if there's a will, there is a way. And some of the nation states are very well funded. You will have to live in a breach. So assume breach, and let's enable exploration so that you're not running with blinders on. So the reality is, how do we make sense of all that data? How do we actually get a representation of the state of our infrastructure at any point in time? And this will become gradual. This is not something that you invest overnight, right? So how do we actually look at the overall system? I started looking at this problem about maybe 5-6 years ago when I started the red team in Azure, where I started having problems in terms of there's too many doors that I can open. Which one leads me to where I need to be, where I need to go? And is there a route to my objective past that door? So it was this huge problem of scale. I was trying to make sense of all this data. Maybe I'm getting old, but the mental graph I was building in my head was just running out of battery. I just could not figure out a way to kind of digest that. But I also felt kind of like the recommendation I was making to people weren't very useful. They were kind of like one trick, and we didn't really kind of enable them to explore further. One important thing as well is to evaluate effort and reward. How do you know that if you spend an amount of effort to resolve an issue, what's going to be the reward? Are you really fixing the problem? Are you playing sort of a whack-a-mole approach? So we weren't really having systems that would enable us to get there. And then the whole concept of regression. What are my expectations? Are they being met now? Are they being met tomorrow? And so on. So very quick slide on sort of a basic tech stack. I do use graph database. I think this is more and more common theme in the industry of using these. I think the main reason was a relational database are not really good at multi-hop explorations and so on. Do use the cloud to actually, automate the whole process. I've built this for Azure in the past, moving to Lyft. I kind of transfer to AWS, somewhat similar functionality. So the idea is you have this Uber graph database that maintains state. Then you have a basic cron job. This is, again, very simplistic infrastructure. You have a cron job that triggers a graph sync. So you're kind of rebuilding the state every time the cron job runs so that you have an updated graph. You can either take an approach of updating the graph, which is a little bit harder, or you can, if your environment is small enough, you can kind of destroy and repave every time. And the graph is a combination of multiple intelligence modules that are responsible to update parts of the graph that they own. So you have AWS in this case, Google API, GitHub. We do use Jira, not Jara. Hopefully I'm naming it right. And the sort of Lyft HR infrastructure like humans, org structures, and so on. All of it is accessible by Lyft employees. So Lyft employees are enabled to go and explore these things as they see fit. And there's a web UI and binary protocol as well that's enabled by Neo4j. So I personally like Neo4j just because of the query language. It translates very well. It's easy to understand. If you have larger data, I think in the case at Microsoft, when I left, we had close to 1 billion nodes and about 2.5 billion edges. Neo4j can scale to that level, but I'd rather don't invest too much on Neo4j clustering. That's all I'll say. There might be other platforms that are better for that. So right now, all what we have is running off their community edition. So it's a kind of a low cost of exploration to actually build a case. And as long as you're not making financial business decision, the licensing allows you to do that. So let's dive a little bit into graph. I'm not using Visio, but it looks like I'm using a lot of Visio. So I'm just representing basic graphs. So if we look at AWS, a very small chunk of the schema, you can have AWS users that are members of groups, and each groups and users are part of an AWS account. Very basic, and an AWS user has access key. Always worry about those access key. We tend to create them and kind of forget, but they do exist. So very simple. You can use AWS APIs. We're currently using I started using the AWS CLI just to go get the data. Again, I'm very new to this whole Mac development and AWS, so I kept it very simple. The engineering is more in the explore phase versus like more mature. So all I do is just use list groups, get groups, list access key, and list users. Very basic. I take the JSON data and import it into Neo4j. So now we have some basic representations of user and group membership, right? We can do the same as well with compute or AWS EC2, where we can have representations of instances that you have, as well as there's the EC2 reservations, the auto scale group, and everything is mapped back to an AWS account. So at Lyft, we do deploy using auto scaling group. So that's why I started looking into the mapping there. And the mapping, again, is very easy. AWS APIs or the AWS CLI will give you the data. So in the case of reservations, instance and membership of reservations is EC2 describe instance. It will spit out everything that's there. And auto scaling group is describe auto scaling groups and will give you the membership. So very simple graph. Okay, now we know like the mapping between EC2 instance and basically auto scaling group. And then we can start augmenting that graph a little bit more with sort of the question is what's installed on those EC2 instance, right? So if we can map that into the graph, we start having a little bit more knowledge of dependencies that we're taking on modules. So what we ended up doing here was quite simple. Just basically list out all the package that's installed on each instance. So you do need some sort of agent on the instance it's themselves, and they can list out the package and write back to the graph, right? So in a very low cost way, you have ways of knowing all packages that are installed per each instance. You can also use OS Query. I think we've been looking into that. To even have more information, but just listing the package is good enough. So you end up with sort of a mapping to each EC2 instance. You don't need any scanning, like host-based scanning for that matter, or the traditional network scanning and so on. You have actually everything that's installed. And right there, you can enable exploration around, what is the most common package that we have, or is our services actually running package that we don't need? So right off the bat, you can start actually looking at trimming down the number of package. And if you enable exploration to your engineering team, they can go and do that themselves. Now, diving more into the security aspect of it, what I'm interested in, let me make sure. Okay, because I always see a slide ahead. I think I was ahead of time. One other investment or one question that I personally had is, okay, we have the EC2 instance, we know the package, what are the vulnerabilities out there? And I'm not a huge fan of a certain company that does network scanning. I've seen them fail miserably over and over. I don't really like that approach. It doesn't scale very well for our environment. So I was kind of interested, and one of our engineers made us realize that Ubuntu actually has a CVE tracker that's accessible for free. And all we had to do is map the package that we already have. We already have the name of the package and the version number. So all we had to do is just sync the Ubuntu CVE tracker and create those relationships. So in a I think it took like a day or so for that pull request to come in. In about a day, we had all packages and all CVE. So that was very, very cheap. And that allows us, again, to explore further. It's like, okay, where are the high risk? Okay, those high risk are related to package. Do we need those package and so on? So right off the bat, in a very effective way, I think in a matter of days, we had that exploration. That was actually pretty meaningful. Now, the side effect of that exploration is when you start measuring. Again, the beginning of change is actually awareness. So you have to, as a intelligence team, you have to kind of disseminate the knowledge. So you have to make people aware about what we have, and it can have kind of a knee-jerk reaction effect, which we somewhat did. I'm not sure if our CISO is here. He actually keeps pretty calm, so I like that. He didn't freak out too much, but he was like, okay, this is kind of interesting data. In my previous jobs, I've had some CISO that would kind of jump in a room. Lift CISO is actually pretty calm. So we had now an awareness of the large debt that we had. We can get a pulse, even though we had a good idea of the number of issues in terms of vulnerabilities that we had, in terms of tribal knowledge and so on, kind of a gut feeling. It was kind of very empowering to see those numbers pop up. But those numbers were sort of like, okay, there's an EC2 instance, right? So we didn't really know who owned that EC2 instance, but at least we had some good data there. The other reality is that when you're looking at that data, everything looks urgent, right? If you look at the number of high or critical and so on, they all look urgent. If everything is urgent, nothing is urgent. Like if your priority is binary, like, okay, either you do it or you don't do it, at the end of the day, you need to make a decision. But at a high level, if you're looking at it needs to be fixed or not, you're not going to make that much progress. I think you need kind of a greater, more calories in there. There's also the sense of avoidance is, well, we already knew this, the problem is too big, let's just avoid the problem or shrug it under the rug, which is not sort of our thinking, but I've definitely seen companies say, we're fine, we're not compromised, or at least we don't know that we are, therefore everything is running fine. So how do you actually tackle this problem? How do you actually make sense out of it? You cannot, I don't feel comfortable going back to an engineering team or an infrastructure team that says, you got to go fix everything. I mean, I can take that approach. I've taken it before a couple of times in my career. That just doesn't work. That doesn't get the needle moving. So what we need is a better insight in terms of prioritization, but also applying more context, business context, to our decision making. Most of the tools out there will spit you out like the CVSS rating and says, okay, that's the truth. Okay, if you look at a 10,000-foot view, maybe, but the reality, the context of our company may change that in different ways, depending on what we want to do, depending on the risk tolerance that we have, depending on the exposure as well. So how do we answer those types of questions in terms of exposure, risk tolerance, lateral movements as well, or what I call transitive risk, which I'll dive a little bit later, is the ability to take a vulnerability that appears low and actually that vulnerability allow you to pivot towards high value asset. How do we actually enable that through our prioritization? So going back to the EC2 instance, so we have a bunch of CVE, right? Very basic example. And we kind of we want to know like a very basic answer. Is this internet or not? Is it internet exposed or not? I mean, if you break down the series of questions, one that comes to mind is that even exposed to the internet? Now, the reality is that you need to worry a little bit more about insider things as well, but I think that's a good way of slicing that. So how we infer internet exposed is, again, we go back to knowledge base. We go back to how our AWS is configured. And that required us to actually augment the graph a little bit more in looking into group membership, network interface. Obviously, what are the network interface? Oh, we're at 10 minutes already. Okay, I'll go a lot faster. Network interface, EC2 security groups, and load balancer as well. And the inbound connectivity as well. So with that simple graph, now we can infer that if I simplify just inbound everything, you can look at IP range down to inbound, down to exposure, and we can infer that, okay, if the IP range is 00000, we can infer that that EC2 instance is actually exposed. Now, from a load balancer perspective, AWS has the scheme internet-facing label, which tells you that this load balancer is internet-facing, so every EC2 instance that are related to that will also be internet exposed. So right there, you've kind of start slicing your risk level. And I'll go fast, but I think those presentations will be made available. On the right side is actually the Neo4j query. So you can see that it's actually durable. One other prioritization is the reality. Is it production? Is it staging? Is it one box as well? And in that case, again, we actually go back to a very simple mechanism is we went back to the auto scaling group, and I realized at Lyft we have a naming convention, which may not be the case for you. If you don't have naming convention for your resource, maybe you have bigger problems. Maybe you want to revisit that first. But in our case, I was lucky enough to have a naming convention for auto scaling group, which breaks it down by service, role, users, and a GUID. So with that information, I can actually infer that if the EC2 instance has an auto scaling group that has production, I can infer that that asset is a production asset very, very easily. So again, apply your internal knowledge, how you can actually infer these things. But for us, it was actually quite simple. I was pretty lucky there. We can also, based on that, infer that based on the service part, we can now associate auto scaling group to a given service. So now we're starting to make the route in terms of identifying EC2 instance to respective service to maybe potentially owners. Let's go try to solve attribution problems. So with a very simple graph, and again, these are hours of work, they're not weeks of work. We were able to produce a patch prioritization by service based on production, internet expose, and the overall patching debt. So now you're making progress. Actually, you can actually go back to your CISO and says, okay, we think that we should prioritize on these ones, which would be production and internet only, right? So that actually allowed us to drive the change pretty quickly. Going pretty fast. The other problem I've seen very often is security engineers are screaming, go fix your bug. But they keep the bug to themselves. They keep it in isolation, either in their own TFS or Jira or the GitHub and so on. So I wanted to actually route the issues, make the engineering team, again, accountable. I do want to drive accountability to engineering team, but I want to enable them to see that. So if the bug is actually filed within their range of vision, they have a better tendency of actually looking at it versus, oh, actually, I need to go look at this TFS or Jira project, Jira project that security owns. Like as an engineering manager, I would not look at that. Not because I don't want to, it's just I got enough things in my plate. So make it visible in terms of my debt. So I was pretty fortunate. Lyft is microservice. So we do have a manifest file that resides in our repository. So I was able to infer quite a bit of data out of that, which allowed me to map to the team and map to on-call. So we do use PagerDuty with PagerDuty policy. So I was able to extract that, interrogate the PagerDuty, and actually start mapping to an actual human directly. So now we ended up having an investment in our HR structure in terms of who are the humans that we have actually in place. And the human can also have like a work term in terms of full-time contractors and so on. So now you can explore like the difference between humans, full-time employees, and contractor access. And org structure, like who fits with which bucket and who reports to who as well. So for us, if you have the G Suite, you can look at reporting structure. If you're using, I did this at Microsoft with AD and Exchange, have that mapping as well. And again, the graph is a living thing. So when people reorg, if you're prone to reorg, like the graph will update itself as well. It actually allows you to uncover that resource has not been fully transferred. You can also keep track of ex-employee, basically terminated users, and verify with the graph if they still have access, for example. So that was pretty meaningful. Now, how do you actually send and make sure that your bug sticks at the right place? I went ahead and interrogated Jira for all our project, and that was a little bit painful, manually curated the team mapping to a project and which attributes of each project would allow you to actually do the mapping. But I only had to do that once. So even though it was tedious, I'm thinking maybe a day of like, browsing around, ended up using the graph to actually give me directions of, okay, who is on call per service? Let me look in Jira to actually see where that person had their bugs. And that usually gave me an indicator of like, okay, where's the mapping, right? So again, the graph will help you kind of do this mapping. So now we had a nice way of actually mapping CVE risks and filing the right bugs at the right person and making it visible to the engineering team, which is pretty impactful. We'll go very quickly. I think I'm. Let's see. Okay, that failed. That did not fail. I just don't see it here. Let's see here. So in Neo4j now, you have a mapping between, you take the CV on the left side down to the human, including Jira project and on-call as well. So now you have a direct route, which you can take and build automation around this. So now you can build this sort of like guided bug cannon that can take multiple inputs of your vulnerability scanner, of your web scanner, hygiene problems or patching, and route all these things, funnel all these things to the right owners and right engineering teams. So for some of you, you're still probably curating these things manually. This will allow you to actually drive the automation hard. Going very quickly, exploring isolation. So most of us have isolation problem. We want to maintain isolation between infrastructure, or from the attacker side, more kind of the pivoting opportunities of lateral movements. We can apply the same structure as well. So if we have an EC2 instance that is deemed to be production true, that is deemed to be production true, and we want to look at, is there isolation between production EC2 instance and staging EC2 instance? We can look at the EC2 subnet, for example. If they share a subnet, then that subnet allows lateral movements. So that becomes very easy to implement if you've already labeled your EC2 instance. So the reality is, if you have an EC2 instance that's production, that EC2 subnet should be labeled as production. But if you have an EC2 instance that is staging, the same subnet should be also labeled as staging. And now the question becomes very easy, is give me all the EC2 subnets that have both production and staging tag, and then you have your pivoting opportunity or gaps in isolation. So you can visualize it through Neo4j, you can use linkers to visualize these things, but you can also return a count and actually measure that risk for burn down, for example. So that's basically it. And furthermore, you can derive automation where you can enable engineering team that have their own assumption, including security and IT and so on. It says, if I can ask a question to the graph that can validate my assumptions, meaning if I query this, it should always return 0. And if it doesn't return 0, I should have a bug. Then you can start building this automation of enabling your engineering team to ask those questions. So that's something that we're currently looking at right now. So, or any deviation from expectation? Yes, everything is good. Deviation of expectation, basically there's a deviation. Go leverage your auto bug filing to actually go clean it up. I think I'm getting slowly kicked out. How much time I have? Like 2 minutes? Okay, let's go real quick. So you can also do blast radius exploration or transitive risks, is what is the impact of a low value asset and actually move forward. So the reality, if you really look at it quickly, if you have, since you have all the CVEs and you have types of CVE, let's say RCE, for example, that will give you an entry point into your environment, especially if it's internet exposed. And you can ask the graph, what are the steps needed to move to a high value target that is not internet exposed? So that can be easily formulated in the graph. Let's see, I'm struggling with these. So you can actually ask that question, and hopefully in a recording you can look back at the query I built. But now you have a CVE. It happens that the same CVE is affecting both instances. But each instance allows a pivoting over the EC2 subnet that we've talked about earlier. And now you can actually see lateral movements possible with a simple CVE. So you can continue exploring. This was heavily leveraged in red team operations in Azure, where we could model TTP that we wanted to exercise, get a quick visibility in terms of the routes, meaning is there enough, if we spend efforts of going through that route, what's the end result? We can anticipate that and actually take that route down to automating, sort of building this Uber botnet. Moving forward, we're looking at applying this to data privacy. How do we map access and validation for data privacy? Service-to-service dependency, let's look at the VPC log, and so on. And if you're curious about how to actually use this approach in a more attacker mindset, offensive mindset. I have a series of presentations I've given over the years that drives a lot more into sort of my attacker mindset. I'm more on the defensive side or risk reduction now. So thank you. Sorry I went fast on the last few ones, but thank you.